All right, y'all asked for this. How do you use a candy bar to show a geologic concept? All right, so take a look at these rocks here. These rocks are flat, they are horizontal. It's actually in geology called the law of original horizontality, meaning that when rocks are formed, the gravity causes the sediments to fall to the bottom, and which forms the rocks, and they form in a very flat manner. So across large distances, you get these flat rocks that are formed. Um, Now, on the other hand, if you're driving around, and many of y'all probably live in places where the geology is very fantastic. Many of y'all do. I'm kind of jealous. It's not so great here in Dallas. There's some, but not very much. But you may see rocks like this. So how do you go from a rock that is flat, that is horizontal, to being something like this, which has what's called an anticline syncline train? It bends up, it bends down, it goes all different ways. Um, how does that happen through the process of deformation? Whenever you try to break a rock, what happens? Like with these rocks here, it's similar to this right here, if you can see that. It's flat, it's horizontal. If I took a hammer to this, what do you think would happen? Well, it break into a bunch of different pieces. It looks like it already has happened in the pieces that broke off. Why didn't it act like Play-Doh and just smash and behave in what's called a plastic manner? It behaves in a brittle manner, it breaks. Whereas these were the same types of rocks, but now they behave in a manner much like Play-Doh, where they will bend and fold and things like that. And ultimately, it comes down to heat. It's heat and pressure. So to show that in candy bar form, I have an ice chest here, and here is the big hunk candy bar that I asked if y'all knew, and nobody knew what it was, and they were actually hard for me to find. They apparently exist only at Walmart and Walgreens here in Texas anyways. As a kid, I actually enjoyed these candy bars, so I was very well aware of them. I like them. Let me open it up first here. So this is the frozen one. And so these rocks at the surface are frozen. So here's the candy bar. Somebody mentioned inclusions, bonus points for talking about the inclusions, but that's not why I use these candy bars. But again, this came out of the ice chest. It was frozen. I'm just going to put a little bit of pressure, a little bit of stress and strain on them in a certain direction, and they're going to break. So very much like this rock here, well, this rock here at the surface, and then this rock, which is very similar to this, they're frozen, they're at the surface. You take a hammer to them, any kind of movement in the earth, they will break. They behave in a brittle manner, and so you get those hard surfaces. They will not bend to form this, what you're seeing here. So what you add is heat and pressure. So I needed to warm up a big hunk. I got one down here somewhere. Again, y'all asked for this. All right, so it is warm now. It has been warmed up. And now it's the same material. It's the exact same thing. You just added temperature to it. So just like that, just under its own weight, it is being bent. It's the exact same material, but now you can easily form those folds. They're anticlines and synclines. So the train of folds can easily happen. So the rock material that's deep within the earth, that's undergoing very high temperature and high pressure right now, whenever there is any kind of tectonic movement in the earth, it's going to fold in that way. That's how it acts. So that's how I use it. Pretty good. So you learned that big hunks exist, and you learned a little geologic concept. So y'all have a nice day.